Welcome back to 10 Applied Math. Today we're going to be beginning a new unit, Solving Linear Systems. A linear system is when you encounter two or more linear equations and you want to find the solution that is common to all of the equations. So before we get into solving linear systems by graphing, I want to review a couple things that we've already discussed. We have spent considerable amount of time discussing linear equations. And so when you have an equation that is in two variables, meaning it has an x and a y, we learned that there was an infinite number of solutions which were called ordered pairs. And I have provided an example here for you. So here is a linear equation. We know it's linear because it has both an x and a y variable, and the exponent on both the x and y variable is 1. So if we were to come up with the ordered pairs and graph this relation, we would get a straight line. And so how do we go about finding the ordered pairs? Well, this is where we created a table of values. So we would create a table of values, and you would choose a value for either x or y. So for example, if I chose an x value of 0, and remember, when you choose x is 0 and y equals 0, you're dealing with the x and y intercepts. So if x is equal to 0, your equation becomes 0 plus 3y is equal to 12. So 3y is equal to 12, and you divide both sides by 3 to get y is equal to 4. So that's how I came up with this 0.04. Likewise, I would choose a y value equal to 0, because again, when x is 0, we're finding the y-intercept. And when y is equal to 0, we are finding the x-intercept. So I would just going to skip down here. I would say x is 0, y is 0. So we have x plus 3 bracket 0 is equal to 12. So x is equal to 12. And so that's how I came up with this 0.12. And then I would pick another value for x. I picked 2, and then I would find its partner y. So that's how we came up with these different points. So these are just 3 solutions to this linear equation, but there are an infinite, meaning there are lots and lots. It goes on and on, the number of solutions. So our definition of a linear system is when we encounter 2 or more linear equations and we want to find the solution that is common to all the equations. So for our purposes, we're only going to be looking at 2 equations. So this linear system, this equation here has an infinite number of ordered pair solutions, and so does this linear relation. It also has an infinite number of ordered pairs or solutions. And what we want to do is we want to find the one point that is common or shared between these two. So it's a point that belongs on this line and it belongs on this line. So the way we're going to solve these questions today is by graphing. So what we're going to do is we are going to graph both of these lines on the same Cartesian grid. And I've actually gone ahead and used the graphing program to do this. But just a reminder, to graph this, the y-intercept is at -4, and the slope is equal to 2 over 1, because this equation is in y equals mx plus b form. So I would go to my y-intercept of 4, I would plot a point, and then using the slope of 2 over 1, I would count up 2 squares and go forward 1, and I would continue that pattern. Plot a point at the y-intercept of +4, count up 2, go 1 to the right, and repeat. Here in the second line, the y-intercept is -1, and your slope is -1/2. So you would go to the y-intercept of -1, and to find an additional point, you would go down 1 and forward 2. Down 1 because the rise is -1, and the run is positive 2. And so that's how you can do a quick graph. Now, when we look at the graph, we're interested in this point right here, where the two lines intersect. This point is a point on each line. And so the coordinates of that point are -2 and 0. So the point -2, 0 is called the point of intersection, but it's also the solution to our system, okay? So where the lines intersect is the solution to your system. Now, you should be doing what's called a verification or a formal check. What we need to do is we need to verify that, in fact, -2, 0 is a point on our first line and our second line. And so we do formal checks. So you take the first equation, y equals 2x plus 4. And we're going to write that as the right side is equal to y, and the left side is equal to 2x plus 4. Just looking at the first equation, on the left-hand side of the equation is y, and on the right-hand side it's 2x plus 4. Now we are going to replace the y value here with the y value at our solution, because remember, it's in the form xy. So our y value is 0. Then on the left-hand side, we replace the x value with -2. And we proceed to clean this up to get -4 plus 4, and when we collect like terms, it equals 0. So now the left side and the right side both equal 0. That means that when I substitute in the coordinates of this point, the conditions here between x and y are satisfied. That means this is a point on the line. We need to repeat the process for the second line. So our second line was y equals -1/2 x minus 1. So again, we separate. The left side is y, and the right side is -1/2 x minus 1. Okay. So I keep the left side and the right side completely separate. The left side is equal to y, which is 0. And the right side, we are going to replace the x with -2. So -1/2 times -2 becomes +1. Then you add it to -1 to get 0. So the left side and the right side are both equivalent. They both equal 0. We have just verified that when you replace x with -2 and y with 0, this equation is balanced. It works out. Okay, it satisfies all the conditions in terms of the relationship between x and y. So this is a point on this line. And so the fact is, because it works in both, we verified that -2, 0 is a point on the first line and the second line. That means that it's a common point, and now we're confident that we have the right solution. Okay, so what you need to do is you are going to take each equation and graph it. In this case, both equations were in y equals mx plus b, so it made our graphing a little bit easier. And once you have the graphs, you are looking for the point of intersection. Where do the two lines meet? You want to identify the coordinates of the point where the lines meet, because that is a solution to your linear system. I've got two examples here where I've already provided you with the graph. All we want to do is identify the solution. So we are going to look to the graphs to see the coordinates where the lines meet up. It's a little bit tricky, but it's at 2 and -5. And over here, we are at the coordinates 6 and 0. Remember, it's 6, 0. Now we're going to do some additional examples, but this time we're going to have to do the graphing. Okay. Now our equations are in different formats, and so we're going to be using a variety of methods to do our graphing. You are definitely going to need a ruler. So in example number 1, we have two equations. They're both in y equals mx plus b form. So that's going to make our graphing a little bit easier. So the first one, our y-intercept is at 2. So I'm going to go to 2, and I'm going to plot a point. And then I need to use the slope of 2. Oh, sorry, my y-intercept is 2. And your slope is 2 over 1. So I'm going to go count up 2 squares and go 1 to the right, up to 1 to the right. And that's going to take me up in this direction. If I want to find points that are down here, I have to do the opposite. So I go down to 1 to the left, down 2 and 1 to the left. And everything should line up. And then you get out your ruler and you connect those points. You put arrows to show that the lines continue in each direction. And I'm just going to call this line A because I don't want to write out the whole thing. I'm going to label that. That's line A. And now we're going to do the same thing for the second line. Here, our y-intercept is -1, and our slope is 1, which is 1 over 1. So we're going to have a slope down here from -1, up 1 over 1, up 1 over 1, and we continue in this process until we find our y-intercept. Now this is a little bit tricky here. And so we're looking for the points where the 2 points intersect. And I believe it's at -3 and 4. Let's have a look. Did I graph it correctly? Sorry, it's at, yeah, -3, 4. Okay, so I want to make sure that that is in fact the correct solution. So I have to do the formal check. So over here, I'm going to do a formal check. So the first equation, y equals 2x plus 2. The left side is equal to y, which is 4. And the right side is 2x plus 2. We replace the x with -3. Clean this up. And we get, that should have been a -4, sorry. There we go. So now the left side and the right side are both equal. So I'm confident that that is a point on the other line. And then we go to the next line, y equals x minus 1. The left side is equal to y, which is -3. And the right side is x minus 1. And our x value was -3. So -3 is, we replace the x with -3. Clean that up to get -4. And again, I made a mistake. So now my left side and my right side are equal, and I am confident that I have the right solution. Okay, so our solution is -3, -4. Now the next group of questions, the graphing is a little bit more complicated because right now this equation is not in y equals mx plus b form. But what we can do is we can rearrange that and transpose the x to the other side and make it negative. And so now we have an equation in y equals mx plus b form. So our y-intercept is at 5, and we have a negative slope. So down 1 over 1, down 1 over 1. And so there's our line for A. And now we want to graph B. Now this is going to be a little bit trickier because of the fractions. It's not so easy to change this into y equals mx plus b. So in this case, you may want to use a table of values. So if x is equal to 0, if x is equal to 0, we're going to get 7y is equal to 0. So y then must be 0. And then we're going to pick other points. So if x is equal to 1, we're going to have 2 times 1 plus 7y equals 0. So 7y will equal negative 2. Y will be negative 2 over 7. So you can see how complicated this is going to be, because this is going to be difficult to graph because there is a decimal there. Well, we'll continue with this, picking different values. I've already got y is 0. Y is 0, x is 0. So that's going to be a point right there, 0, 0. So let's pick, let's 3, 4. It's really up to you. Actually, you know what we can do? We can rearrange this into y equals mx plus b. I was mistaken there. So 7y equals minus 2. So y equals negative 2 over 7x. So my y-intercept is 0. And my slope is negative 2 over 7. So sorry, I could rearrange that one. It wasn't so bad after all. So what we're going to do then is my y-intercept is 0, and I'm going to go down 2, and I'm going to go forward 7. So right there. And in fact, there we go. There's line B, and I can see that the point of intersection is at 7 and negative 2. And so now we have to go through the process of doing a check. So we have x plus y is equal to 5. The left side will be x plus y, which is now equal to 5, and the right side is 5. So it works in the first equation, and then for the second equation, we're going to have the left side. So we have the equation 2x plus 7y equals 0. We're going to replace x with 7, y with negative 2, so that becomes 14 plus negative 14, which is equal to 0, and the right side is equal to 0. So the left side equals the right side, so we are confident that we have the right solution. Okay, so in both these questions here, we took the equation, it rewrote it in y equals mx plus b so that we could do some quick graphing without a table of values. In example number 3, we can do something similar. So we've got 2 equations. Neither one of them are in y equals mx plus b form, but this one here we can rearrange to get 3x minus 4 is equal to y, or you can write that as y equals 3x minus 4. So that means we have a y-intercept of negative 4 with a slope of 3. So I'm going to count up 3, sorry, negative 4. I'm going to, and then we'll go down 3. 1, 2, 3, 1 to the left. I'm going to connect those. I didn't do such a good job there. So that's line A. And then we're going to graph line B. Now remember, you need to have at least 2 points, if not 3. Now we could take this equation and put it into y equals mx plus b. So that would be 2y equals negative 7x plus 18. Divide both sides by 2, everything divided by 2. So y equals negative 7 over 2x, and 18 divided by 2 is 9. So our y-intercept is at 9. And then we're going to count down 7 and go forward 2. Oh, there we are right there. I can see the point of intersection is at 2, 2. We landed right on a common point. So it looks like the solution is 2, 2, but I need to do the verification. So I go to my first equation. The left side, we're going to replace x with 2 and y with 2. Clean that up. 6 minus 2 is equal to 4. And the right side is just a 4, so the left side is equal to right side. That tells me that 2, 2 is indeed a point on this line. Then we do the second one. The left side, so our equation is 7x plus 2y equals 18. The left side is equal to 7 bracket 2. We're replacing x with 2 plus 2 times y, which is 2, which becomes 14 plus 4, which is equal to 18, which is also the right-hand side value of 18. So the left side is equal to the right side. And our last example, you'll notice that y equals 8 is something a little bit different. This is one of our special types of lines. Y equals 8 means y is always 8, no matter the x value, which means we are talking about a horizontal line that has a y-intercept at 8. This is the line that we're talking about. So we're then going to graph the second line, but we know that in order for these two lines to intersect, it has to be at a y value of 8. Now this equation, we can rearrange it to 5x minus 2 is equal to y. So I'm transposing the negative 2 to the left, and the negative y goes to the opposite side. And if you just rewrite that, it's 5x minus 2. So now it's in y equals mx plus b form. Our y-intercept is at negative 2, and we count up 5. 1, 2, 3, 4, 5, and over 1. And then we go up 5 again, 1, 2, 3, 4, 5, and over 1. That's line A. Then we've done line B. And the point of intersection is at 2, 8. And then you go through and you would repeat the process. Obviously, for the first one, it's correct. So we just want to verify in the second equation, 5x minus 2y is equal to 8. The left side becomes 5 times 2 minus 2 bracket 8. So that becomes 10 minus, 5 times x is 2, y is 8. So 10 minus 16 equals minus 6. Just a second here. Oh, I'm going back to this one. So it's the 0.28. So when x is 2, oh, it's only 1 y. That's my mistake. So it's going to be 10 minus 8 is equal to 2. And my right side is equal to 2, therefore it works. You can see that I actually just made an error there, and I was recognizing that my left side and the right side were not the same. So that meant there was an error, and I started to backtrack a bit, and I realized I'd written a 2 there when I shouldn't have. Okay. So now that we've gone over solving linear systems by graphing, you have to go back and use the skills we learned when it came to graphing linear relations by taking your equations and putting them into y equals mx plus b so that you can do a quick graph, or you can use a table of values.